So, good morning, everyone. My name is Leonidas Pitsikas, and I'm from People Technology Solutions, and I welcome you to the Pixel Closure event, which will take place from now until 1:30 Central European Time. First of all, I have to inform you that this session is being recorded, and I also want to explain to you how to control this, how you can ask questions. In the right top side, you can see one reaction, which is to raise your hand. You can raise it, and we will monitor this and log it and ask you to ask the question later on. Or you can also write your question at the chat box, which is also on your right-hand side of the monitor. Now, what is this event is about? This event is about Pixel, which is a project founded by the European Union in the framework of the Horizon 2020. And Pixel, which means port Internet of Things for environmental leverage, which is the first smart, scalable, flexible and solution for reducing environmental impact in the ports. In the framework of the dissemination of this project, we are holding this closure event, where we will present the finalized product to the community, and we will inform you of the needs we're addressing. We will showcase some pilot ports. We have run in some pilots. We have run in 4 major ports in Europe, and we will also inform you about the Pixel consortium, which is going to be presented at the end of the event. Now, Mr. Ignacio Lacalle will present the agenda of the event. Nacho?
Thank you very much, Leonidas, for the kind introduction. Let me very quickly share my screen because I will just guide you a bit through the agenda for the sessions of today that are planned. First of all, I would also like to thank you all for having come to this final closure event and to welcome you to the day of today, in which we will be reviewing what we have done in more than 3 years, almost 3 years and a half, and after hard work, what we have achieved in the Pixel project. Sessions today will consist, or will be divided in 4 main blocks. The first one starting right now about what has been Pixel as a completed action, what we have achieved, what we have pursued, and where we are actually standing in terms of the ports of the future provision. Afterwards, we will pass the floor to relevant keynote speakers we have been working with and that will relate their experience with Pixel. And afterwards, we will make short demonstrations of how our product can be used, in particular the Port Environmental Index, which is the flagship outcome of our project. Finally, we will pass the floor to our innovation manager, that will be pleased to announce the launching of the Pixel Association. You will all know what this will consist in few minutes. So, the floor is yours again, Leonidas. Thank you.
Sorry, my microphone was mute. At this moment, we will present the overall conclusion of the project. And the goal is to showcase, the goal is to present the Pixel conclusion, to give you some figures, to tell you about the pilot achievements, the outcomes, the overall collaboration, the papers, etc. The presentation will be done by Professor Carlos Palau. So, Nacho, if you kindly introduce Professor Palau to our viewers.
Yes, of course. Thank you. Well, Professor Carlos Palau is the project coordinator of Pixel. He is also coordinating other H2020 projects such as Assist IoT, and in the past has coordinated other projects related with the IoT world, like InterIoT, and is a full professor in the university and has more than 25 years of experience in this research field, and he will be introducing the results of the project. So the floor is yours, Carlos. Thank you.
Okay, Nacho, thank you very much, Nacho, for the presentation, and thank you, Leonidas, for organizing both together with the rest of the consortium this wonderful event we are having today. So we are coming to an end of the project. The project started 41 months ago, as Nacho has said, nearly 3 years and a half, and with this event and with the presentation that I am going to make right now, the idea is to show Pixel as a finalized project. Okay, so what is Pixel? Pixel, how do we consider Pixel? We consider Pixel a place, an environment where IoT meets the port of the future. The idea is that Pixel will be in the middle. We have the ports, we have IoT, that is the technology, and the goal is to make or to achieve a good environmental impact thanks to the use of Pixel. So the port of the future has to be green or will not be the port of the future. This is something that has to be considered and has to be important. As we will see later on, we have 4 ports involved in the consortium, and all the testing and all the trials, and 2 are in Greece, 1 is in Italy, another 1 is in France, as we will see later on. So, what is the origin of Pixel? We consider that Pixel is a good solution for the challenge launched by the Commission. We have been analyzing the statistics about the ports, about the investments in money, the number of tons managed by the different ports for many years, and it's a typical figure that we use a lot in the lab in the university to analyze different things. It's the typical Pareto structure of an statistical distribution in which we have not many ports, 10% of the 20 ports, which manage 60% of the total tonnage of goods transported in Europe. It was the data of 2017 when we launched the project, and we have a very long tail of 90% of the rest of the port that altogether they are managing 40% of share of total tonnage. So actually, there are more ports that are managing not so many products, but it's the typical theory of the long tail economical analysis. So then we have to think: is there a better future ahead for the ports of the long tail? It will be to analyze or to check different challenges that are faced by this kind of ports. For example, we detected 5 is the efficient data capture to be able to continuously drive decision making on them, because many times there is not efficient data capture, data is not available, data is not in where it has to be. The heterogeneous operational data integration is not or was not or is not very good in these long tail ports. The decision making, the operational decision related with environmental impact remain unclear. Why this decision is made, which impact is going to have. Many standardized practice regarding the integration, the reporting of the environmental impact of the different operations are missing. They are usually not in place. The port is small, not many ships arriving, and additionally, digitalization is moving at very, very slow pace. Why? Because typically in a long port, and the investment in communication infrastructure can be, let's say, rentabilized quite fast. but in a small port, you have to invest a lot of money just to put not so many sensors. So digitalization is going slowly in these long tail ports. So we try to provide the pixel approach in order to try to solve this digitalization port that is far from optimal. One of the drawbacks is that there are a lot of untracked environmental impact. So we started to work as a problem-driven approach with clear statement of the problem, identification of the novel concept. We try to evolve the state of the art and demonstrate in relevant and in real use cases in a closed loop in order to do this. So dealing with port complexity and heterogeneity, considering that there is no clear open source reference platform, we can find vendor lock-in in different areas of digitalization, and in some cases there are restrictive old-fashioned regulations regarding different aspects. So this heterogeneity on ports ecosystem reality include many actors. Many actors playing different roles that we have to orchestrate somehow in order to be able to launch Pixel as the first smart, flexible, and scalable solution for reducing environmental impacts while optimizing different operations in the port ecosystem that we are dealing with through the from virtual sensors. And the 4 ports that together with us started this journey were the port of Monfalcone in Italy, the port of Bordeaux in France, the port of Piraeus, and the port of Thessaloniki in Greece. So we started from complex scenarios in order to reduce the environmental impact of port activities, reduce the operational cost, improve the different logistic efficiency in multimodal hubs as are the ports, better port city integration. We had the different ports that are involved in the project are in this kind of port city integration, and very important is to provide less dependency on the different technology providers in order to avoid this vendor lock-in, in order to avoid or to open the possibility of including new solutions coming from new manufacturers, new vendors. So these complex scenarios, we have to develop multiple tools that are around Pixel, having different modular components included in a single platform. Then we will the different modular components that we will be seeing later on, okay, inside the Pixel platform. Here, we aim to have realistic innovation certified by the evaluation of the different ports. So we have Pixel, and here we have the different data acquisition agents, data acquisitions from the different sensors deployed in the ports, from open data, from processes, from third-party components or information systems. Everything coordinated through the information hub, as we will see later on. A model orchestrator in order to orchestrate the different models that we have been developing in order to model this environmental impact. The Pixel dashboard, because at the end of the day, we have to show in a flexible Pixel dashboard the different information and the different data that is presented and is shown by the data that is being gathered, and having the index for ports, terminals, and vessels as a composite index in order to evaluate the environmental impact. The PAS for the different models, having the environmental pollution, energy demand, and we introduced due to the pandemic a new COVID-19, which we have published in different papers, and developing different algorithms, as we will be seeing later on in some of the demos at sea and on the road. All this work regarding the Pixel platform, we have detected and we have 4K exploitable results. 4K exploitable results, later on, Joao will be introducing this when in his presentation. We have the Port Environmental Index. We have the Maritime Data Analytics.
Carlos, May I interrupt you for a second? Can you please hold the microphone a little bit further from you, because
Yes.
it makes some.
Okay. Sorry, I was putting it close because sometimes they say they hear me very low. Sorry. So we have a 4K exploitable result, the port environmental index, the maritime data analytics, the big data engine, and the port activity scenarios that are key exploitable results, but are not the only exploitable results, because we have detected other potential exploitable results. So the Pixel as a technical solution. Pixel as a technical solution has the typical structure of an IoT platform, okay, in which we have a preliminary sensors that are deployed, the data acquisition agents dealing with the different elements that are providing information. We have a data acquisition broker, in which we are gathering all the data. We are, together with the information hub, we are homogenizing the data that are coming from the different sensors of the data sources gathered by the data acquisition agent. All the platform is powered by Firewall. We have selected an open source solution for IoT platforms, which key component, the core component of Firewall is Orion, and we have placed Orion as the component in the data acquisition broker. It allows us to introduce the concept of context awareness that we will be using, we have used it in the Pixel project, and in the information hub with known open source solutions like Apache Kafka and Elasticsearch, and on top of the information hub, the different operational tools that are providing different analysis of the data that we are receiving, and later on over the operational tool, the dashboard that is presenting the data or showing the data to the users. And of course, vertically, we can avoid two concepts that are security and privacy to manage the whole platform, as having a platform like Pixel without security and privacy is a nonsense currently. Okay. So all the operational tools have been virtualized and containerized using Docker in order to make it easy this modular approach that we are proposing in Pixel. So a part of the technical point of view, we have the user-oriented point of view, because we want Pixel as a user-oriented product. We have been listening different stakeholders. We have been gathering requirements with the different stakeholders. We have been doing the different tests in the ports and listening and presenting, as I will tell you, in more than 40 events, listening the feedback or gathering the feedback from different users in order to improve the Pixel approach. And from the point of view as a user-oriented product, Pixel is the first IoT integrated platform focused on the optimization of operation and reduction of the environmental index. In fact, PEI, the port environmental index, is a quantitative composite indicator for the overall environmental performance of the port as a novelty. We provide secured dashboards with the operational tools in order to provide support to decision-making from the different agents that are managing the operation in the ports, with real-time monitoring and also with predictive analysis. And we also provide the information hub in order to use different smart models, energy, transportation, pollution, and also the port city integration in order to optimize the different operations. So in which cases has Pixel been tested? And of course, providing an open invitation for newcomers in order to test the Pixel approach. We have had the port of Thessaloniki, the port of Monfalcone, the port of Piraeus, and the port of Bordeaux. We have had the port city integration use case, in which we have evaluated this use case with different data and the evaluation of this model. The energy use case, also the pay use case that has been traversal to the different ports, and the multimodal use case. The port city integration has been tested mainly in the port of Thessaloniki, the energy use case in the port of Bordeaux, and the multimodal use case in the port of Monfalcone. So the idea have been 4 use cases, 3 small and medium ports that have demonstrated the validity of the project results, and the port of Piraeus as a large port in order to assure result scalability and achieve or demonstrate that the different things that we are testing in the long tail ports can be also tested in a very big port that is in the 10% of the ports that are handling the 60% of the tonnage of the goods. And here you can have your port that can be included in any of the use cases, or it can be modeled with different use cases using different models through the Pixel platform. So who has made Pixel become a reality? So, you know, I have I'm honored to make this presentation of the overall results of the project when it has finished, but it would have never been possible without this very hard work, in sometimes even more hard work that was planned in the beginning, because we have to overcome the pandemic, we have to overcome different problems and so on. Without this has been the consortium that has made possible that Pixel become a reality. UPV has coordinated the project, but we have incredible partners like Orange from France, ProDevelop from Spain, XLab from Slovenia, Katie from France, Inciel from Italy, Criocean from France, Medri from Croatia, SDAC from Italy, Certh from Greece, People from Greece, and the 4 ports that have supported us, technical people requesting many things, and have been able to make and to deploy wonderful pilots like the port of Bordeaux in France, the port of Piraeus in Greece, the port of Thessaloniki also in Greece, and the port of Monfalcone now integrated with the port of Trieste in Italy. So how Pixel looks like, how do we do this specific data gathering? For example, you can see some sensors deployed, the dashboard as is being seen, different communication antennas and different sensors deployed in a port. We can see here the use through a single window of everything that is being gathered and is being shown. Here we can see the flexible dashboard with different data, the Maritic data analytic, and the security entrance to the dashboard and to the platform. This is also how it has been piloted in real ports. Here we can see the different screens, how the port operation, one of the port operation managers, one of the end users, is handling the different screens. On the center, on the right, is managing tools from the port, and on the left, the new Pixel screen. And we can see here some of the scientific excellence that we have achieved in Pixel. We have published 23 articles, 4 in Q1, Q2 of relevant journals. We have presented it in more than 15 conferences in IoT and in the environmental sector, also in the maritime sector. And through all the project, we have been really committed with open source. We have contributed to open source initiative, for example, Firewall, and we have provided all the code available in GitHub in order to be used by the community, more than 12 repositories for the information. So we have tried to be excellent in the scientific part, and also try to contribute to open source community. We have participated in 46 events in which Pixel has been pitched. We have become a member of AliCTP and also of IEVP. We have successful collaboration with different stakeholders and different organizations like ESPO, WPSP, Port CDM, and other relevant entities of the sector. We have had conversation in order to disseminate and to, let's say, introduce the results of Pixel. And through the lifetime of the project, we have to say that in the cluster of projects, we have had a very good collaboration with Coriolis, Port Forward, and also with Docs the Future. So thank you for the presentation. I hope, Leonidas, that I have stick to the timing that you indicated. Sorry if the microphone has made some noise. I don't understand the reason, but if there is any question, or we go ahead. Leonidas, you are the master of ceremonies.
Thank you very much, Carlos, for this very good and very complete presentation. We don't have yet any questions. I suppose that we can go on with the next topic in the agenda, which is a tour around the platform that will showcase the Pixel dashboard, that will navigate through the global spaces and models, and will explain the traits of this IoT platform. Basically, we will see what this product is about. The presentation will be done by Miguel Angel Lorente. And Nacho, if you can please introduce Mr. Lorente to the rest of the group. Thank you.
Yes, absolutely. Thank you very much, Leonidas, and thank you, Carlos, for your presentation. The next session for the tour around the platform will be conducted by Miguel Angel Llorente, which is from ProDevelop and is the technical coordinator, or has been the technical coordinator of Pixel Project. Miguel Angel is a telecommunications engineer and has more than 10 years of experience in project and product management, and is currently a group manager at his company, leading the company's business line in maritime and port terminals, which is his sector of specialization. So, Miguel Angel, the floor is yours. Thank you.
Hi, hello, good morning. Thanks for the presentation, Leonidas and Nacho. Thanks also, Carlos, and for the previous presentation, and everyone for joining today, this important day to us, which is the closure event. I was about to introduce myself, but I see that Nacho has done very well. So thank you very much. So first of all, I would like to explain a little bit the philosophy of the development of this visualization tool. I mean, what we are going to see is what is seen by and interacted by the user, but behind this there is a lot of things running and working together. As you have seen on the presentation of Carlos, the data acquisition layer, the Pixel Information Hub, the backend of the operational tools, and so on and so forth. So a lot of things are running behind the scenes. So I'm just showing you the scene of what the end user actually sees on their screen. So we have relied a framework that uses Vue.js technology, okay, which is in turn a JavaScript framework. So we are using a framework on the top of a framework. This technology stack allows us to create simple and fast visualization elements common in the modern world. One visualization element could be this one that you are seeing now on your screen, which is the login. This is a component that comes with a framework, so the UI part we just personalize and that's it. And on the backend, all this is working with specific components. We use templates on database to personalize, to customize all the visualization. So if we go to the different pods, as the different pods has different use cases, they will have different templates of visualizations. And I will show you a little bit how it works. But basically what we do is to rely on existing frameworks, open source frameworks, and then use templates in order to make easier and facilitate the experience of the end users, that they don't have to be technical or very well trained, let's say, on the usage of complex technologies. The application framework, allow us, as I was saying, to generate predefined components such as this login. This login, or for instance, the authorization tool, works with a backend based on Firewall. So when I press this login, I have contacted the identity manager of Firewall, and I have checked that this user was on the database, and I have returned the authorization to see all the menus that we have here on the left. We use the Firewall backend to everything related to security, and also to the data for the data acquisition layer. But with regards to security, we use these backend features. In the main view of Pixel, we can find a sidebar, like here, that it's composed in turn of a series of menus that we can click, and they will generate a tab on which navigate. So if we click different menus, as you see, we generate different tabs that we can also close. This sidebar contains all the aspects we have developed in the treatment, exploration, representation of data and models in Pixel. So everything that we have been working on have a visual tool to be managed and is on this platform. So that's why there is a single screen for managing all the Pixel platform, a so-called platform, because actually it's a tool set that we have developed a platform on top of it. The main view of, for instance, okay, let me, this is the first view that we get on Pixel when we arrive on Pixel. This is the overview. This overview shows all the charts and visualizations and tables and so that have been created and with the data stored in the Pixel Information Hub. Here we have the example of Thessaloniki, which have a specific visualization for traffic monitoring or the gates occupation or the gates congestions, better said. And then we have tables with the specific data. We have data series representation, histograms that can be navigated, and so on. Okay, all these views are created in the Views tab. In the Views tab, we have a summary of all the views created. Some of them are activated and are in green, represented in green, and some of them they are hidden for this specific user. We have, as I was saying before, we have created a wizard to make easier to the end user to create this kind of visualization. So, for instance, in the case of Thessaloniki, we have custom visualizations, visualization for the port activity scenario. I think that this will be discussed later, the port activity scenario, but essentially is a model we create to represent the functions and how the different blocks of the pod relates together. The air model, the air dispersion models, the noise model, or the traffic monitoring. So as Thessaloniki has these 4 modules activated, they have 4 different wizards that we can select. In this case, we are going to create a custom visualization. In the custom visualization, we have so far an iframe that brings the data from an external source, or a data table. So if we enter a title such wind demo closure event, then we can select on the Pixel Information Hub where to get the information. We have a couple of ways to select this information. If we create an alias to make easier the selection of the data, but yeah, we are seeing let's say the developer view. And then we select the fields, the station code, station name, for instance, direction, speed, that's it. And then I limit the query size and I get the rest by default. I add this. Then if I go to, I have added the new visualization, wind demo, I activate it. And then if I go to the overview, in the lower part of the dashboard, I will get this table with the values, with the actual values. I'm seeing a pop-up. So if there is a question, please tell me, okay? Because I can't look at the chat.
Please, Miguel Angel, go ahead and we will address those at the end of the session.
Okay, because I see the bubble of someone asking or something. Okay, then I go ahead. Then we have the permission tab. In the permission tab, very easily we manage users with the identity manager of Firewall. and the permissions they have according a role, also managed by Firewall. Okay. Then we have the Pass Information tab, where we define the logistics and how the different components relate on a specific pod. This is very important tab, because there is a specific way of relating the things in each and every pod, and we can't generalize that. So we need to provide an easy way to let the pods to say, okay, I work this way. This is my model of relation. So in this menu, you can relate the pollutants with the energies that you are using, the equipment, the machines. I mean, the equipment that you are using to do your operations. You can see here typical equipment, gantry cranes, straddle carriers, and so on and so forth. Then the areas of the pod where you are working, how they, the main processes, container unload, dry bulk unload, general cargo unload, the type of freight, let's say, that is managed by the pod, and then a button to send to the information hub. So this is very important to define the model on how the pod work specifically. Okay, in the agent tab, the next tab, agents, we can see all the data captured and collected, which is running in this particular instance of Pixel. Although the view is still admittedly rudimentary is a view more oriented at this time to development or to proof of concept. Keep in mind that this information is available, so we actually can explore each and every data source, each and every agent that is running behind the scenes on a single view, and we can check if the agents are not well deployed, if there is something missing, or what is exactly running on all the platforms. So this is also an important view, and this lists all the resources on the platform. The map tab, there's coming a little bit of noise from someone. Please, can you mute? Okay. The map tabs reflects a geospatial view of the pod. Okay. In this case, we have in the map tab, everything that is declared with a fixed geospatial view is represented. In this case, we have a couple of sensors. I have a mouse with a lot of sensibility, so if I zoom in, it will do several zoom-ins at the same time. I have to be very okay. So these sensors appear automatically when they are declared, and they have a position, a geospatial position, as I was saying. And if they do periodical measurements, as it is the case of this sensor, we can click. We focus on this sensor, and then if we click details, we get the time series representation of the sensor, as you see here, and we can navigate through the historic data, and also we get all the fields that the sensor is measuring. Okay. Going ahead, we have the alerts tab. In the alert tab, it's a tool for setting up alerts, showing those that have already been set up, and also it shows a small wizard to create these alerts. The alerts can be used both to detect outliers, to set some limits and detect when the limits are overpassed, or to set thresholds. In this case, this template, we have simply established two type of alerts. average minimum, average maximum, okay, for a time series. We can then give it a name, select a field and an index, and we have already this alert set up. Okay, the alerts is connected to a complex event processor, which is also used by the operational tools, and they are continuously analyzing the data coming in the information hub. Precisely in the next tab, we can see the operational tools, which manage all the models and predictive algorithms that have been registered in the specific instance of the platform. And we also have access to a tool for the evaluation of KPIs that, as said, it works with the same backend. The backend is called ElastAlert. It works with the same backend as the alerts tab. So here we can see that we have different models running, pink model, a port environmental index, the pass model, etc., and also predictive algorithms. In this case, the predictive algorithm for traffic. Okay, then we can configure this. We can schedule that the algorithms are executed once a day or once each n hours or whatever. We can manually run, or we can delete the model. Also, we can add new models by that are deployed, and we could see them on the agents view. Okay.
Sorry, Miguel Angel, for
Yes.
interrupting. Should be finalizing in 3 minutes, just for you to plan your.
Okay. Okay. No problem. No problem. Yes. Yes. We are reaching the end of the work around the platform. Yeah. The next tab is the port environmental index. I know that this is going to be, well, we all know that this is going to be discussed afterwards, so I won't stop much on this visualization part. But as you see, we can, we have different visualizations and different information tabs regarding the Pixel port environmental index, which is a major achievement of the project, as Nacho and Carlos has said before. And finally, we developed a COVID-19 special. Oh, sorry, this is about my mouse, not the platform. COVID special visualization. This based on the port activity scenarios and based on the activity on the terminal, we determine the risk, the COVID risk during the activity of the typical activities of the port. Yeah, and finally, since some algorithms and models could not be integrated directly into the platform, as they are separate tools that don't provide integration or API, we prepared this upload button in order to upload the information of the external providers, such as the noise and the air propagation models, and we can upload the results of these models here by getting the data manually, and then we can observe on the same screen the results of everything. And this is it. I think that we have just given a glimpse of what has been developed and what is the scope of the project and how is shown to the user. You can see here other perspectives of Pixel or the pods, indeed. So, and with all the different scenarios. This is Monfalcone, for instance, and this is for Bordeaux. So yeah, if you have any questions or any comments, I gladly can answer.
Thank you, Miguel Angel. Actually, we have 3 questions.
Yep, okay.
Up to now. The first one is from Peter Breselet, and Peter is asking, what is the maximum time frame for the prediction of traffic? I understand that Nacho and Benjamin have already answered that there is not any theoretical maximum, but accuracy decreases as this is lengthened.
Obviously, yeah.
And also, please confirm Nacho's reply that at this point, usually we're using weekly based predictions for the traffic.
Yeah, that's it. As I have said in the chat, we are using currently 5 to 7 days of time horizon prediction for the traffic models, but actually the maximum theoretical maximum is as far as you would wish, but of course with lower accuracy as you increase the horizon time. So we, after some tests and statistics studies, agreed that weekly basis horizon was the best way to approach this.
I don't know if Mr. Brasilier would like to speak and comment on this, or I understand if there is also one more topic that you would like to cover.
Yes, thank you, Leonidas and Ignacio. Now, I was wondering actually if it's linked to booking time slots for trucks to arrive at the gate, or is it just based on a prediction actually? Because it would be interesting to have all trucks actually booked their visit to the gate from that point of view. And then later on, you can also start to give them a score on how green their visit is actually, based on the truck, based on the time of loading, these kind of things. And what I think in future will happen, I've already seen it in African ports, is that every truck has to pay an entrance fee at the gate now, which is becoming a bit more logic. So if you consider the environmental issues of trucks loading in a port, actually, if you come during peak hours, it will be more expensive than in off-peak hours, these kind of things. So these are concepts which might be very close to reality, I think. So if it can be linked to this application, it becomes very interesting indeed.
Yeah, well, actually, for traffic prediction, we have followed different approaches depending on the pod, depending on the case. As you would imagine, one of the challenges is to adapt to the different data sources that a pod have available. And yeah, indeed, this is a further work to explore, which is to relate with the carbon footprint of each and every operation, especially considering that the vehicle booking systems are spreading, and but they usually are not respected, let's say followed. So you may have a booking, but if you come later or before your booking, then your container, for instance, won't be ready, and maybe there will be more movements to be done to your container because of the fact that you haven't come at the specified hour. And this is something that we are working on, not specifically in Pixel. But yes, it's a reality. Coming back to Pixel, we had the challenge, but the lucky at the same time to have different scenarios in Piraeus, Thessaloniki, and Monfalcone with different data sources. And then, if I'm not wrong, and correct me if so, in Monfalcone we did have the parking slots. We have the cameras of the road, so we could make better predictions. And for instance, in Peru, we were using external data coming from public sources. And yeah, we experimented the differences. But yes, as far as we have this as far as we have the data resources available, what it comes to the prediction algorithms is somehow straightforward. Is feeding these algorithms, training them, and try to get the best prediction possible.
Thank you, Miguel.
Thank you, Miguel. One other question by Mr. Joris Glaze. It's about does Pixelport automation, the pay and the platform dashboard tool include and/or contribute to the last mile logistics of the port hinterland,
No.
road, rail? However, Nacho already gave an answer to this question on the chat. But I think that it is also a good opportunity to say a little bit about the modularity of Pixel and the expandability, which also Joao will speak about it in a while. But if you can also, Miguel Angel, to explain how different modules and algorithms can be inserted in this platform.
Yes, actually, as I have just outlined in my answer, not isolatedly from the direct question in the PI, because the attributable origins of the impacts and the impacts themselves have been, let's say, constrained or defined in the scope of our task and in the limited state of the project, but it's considered, of course, for the future. However, the connection of the outputs from one model to the inputs from another, the relation among them is clearly boosted and endorsed by the modularity of the platform, as Miguel Angel has represented. So it's completely possible to associate, for instance, the time that the hinterland model results have provided with the input results of another type of model, such as the PEI or the traffic prediction, and correlate both results, visualize them together to help decision making in any sense. So, and in addition, thanks to the scalability and flexibility in the technical way Pixel has been designed, new models can be constructed on and upon those results. So ad hoc specializations and customized models for obtaining certain results are completely feasible ad hoc in customized ports. Yes.
Yeah. I fully agree with you, Nacho. In Pixel, in the end, we planned to focus on the emissions and the impact of the pod activities, and not the pod activities, but directly related to the pod. But obviously, and this is one of the design constraint that we put ourselves, is to be flexible and scalable by design. First of all, because otherwise it's not possible to reach to all sized ports, because this has to be easy to maintain, cheap to maintain, to be clear, and something is not cheap to maintain if it's not scalable, if you can't put new modules when you need it, and so on. Then yes, new features related to the last mile could be added, and that would be relatively simple to do it, obviously following the guidelines of Pixel that are published. But yeah, potentially it's possible, but this is not the scope of the action.
Thank you very much, Miguel Angel. I suppose there are no other questions, and we are some minutes behind in time. So without further delay, let's move to the next topic of the agenda, which is the user story and feedback. And this will be the explanation of the experience of having participated in Pixel as part of the user design by one of our ports, which is one of our pilot trials stakeholder, and it will describe the pixel potentialities in ports. The presentation will be done by Fabrice Klein. So please, Nacho, if you can introduce Fabrice. Thank you very much.
Yes, of course. Thank you, Leonidas. And this session will be presented by Mr. Fabrice Klein, which has been, let's say, the project manager involved in the day-to-day action in Pixel from the Grand Port Maritime of Bordeaux since the beginning of the project. He's an expert in maritime and harbor innovation technologies and IT, and since 2016, he's a cross-functional innovation project manager and deals with research and development projects linked with environment, navigation, port digitalization, decarbonization. Thank you very, very much, Fabrice, for willing to present here, and the floor is yours.
Thank you, Nacho.
You can share your own screen to present.
Okay. Nacho, you can see my screen?
Yes, very good.
Okay. Thank you.
Yes, Fabrice, go ahead.
Okay. Port of Bordeaux is happy and proud to talk about its experience on the Pixel story, because environmental indicators like Pixel are become necessary for port decarbonization. Indeed, for our organization, concentrating both logistical and industrial activities, and also our complex interfaces between land and sea or river, and between city and the world. Historically, they are places of commerce, production, and trade that concentrate raw materials, energy, and human wealth. The maritime world has undoubtedly experienced phenomena of scale which have profoundly transformed port area for several decades. The abundance of oil and gas made it possible to limit their costs, allowing the unbridled dynamism of these large port hubs. At a time when the planet is threatened by the overexploitation of its non-renewable resources, global awareness is growing. It's now a question of seeking sobriety, frugality, and pragmatism. Environmental performance indicators have become necessary. Thus, Port of Bordeaux, located on the largest estuary in Europe, aims for environmental excellence and actively works to decarbonize industrial port activities. It's also involved in several UN parent collaborative research and development projects related to the environment, energy, and in particular to the production of hydrogen for the first short-term use like biofuels. Pixel is an important collaborative project in which Port of Bordeaux big data, artificial intelligence, IT developments, scientists expert in many fields, including medicine, and thus allowed the Port of Bordeaux to be looked to the future and imagine with experts the green port of tomorrow, while on the track to decarbonization. During the project, discussions were reached to allow everyone to understand what a port is, what happens there, and how it works. Or more precisely, to discover the particularities of the different parts of the project, Falcon, Thessalonique, Piraeus, and of course, Bordeaux. This contributed to the richness of Pixel. In particular, Pixel had to integrate these specificities and seek to adapt with the greatest flexibility to many ports configuration. The flexibility and scalability of Pixel being key element for its replication in other ports. But it was also necessary that the ports understand methodological approaches, contribute to the choice of those which are best suited to the project. and the exchanges were sometimes tough when the point of view were not the same. It's also this human exchange that made the richness of the project. But results are there. Pixel work with data from ports, and we are all proud to contemplate work's result by exploiting the latest technology to measure these environmental efforts. Indeed, existing environmental programs such as Grand Marine, for example, deprived of IoT technology, adopt a process based on environmental approaches, but without physical data. Thus, Pixels P give a score calculated from physical measurement, which is innovative and complements existing tools. And if there are still actions to be taken into account in Pixel, such as the new water injection dredge running on LNG, we have now a picture of our environmental performance, which will now make it possible to monitor the fruits of our decarbonization efforts. We can now touch with our fingertips representative indicators of the activity of the Bordeaux docks. But Pixel is not limited to the P. It also explores other functionalities such as forecasting stopover time for improving power services or energy aspect. Indeed, the Port of Bordeaux seeks to reduce its emission directly at the source by seeking not only to reduce its energy consumption, but by better controlling its energy needs to become as much as possible self-sufficient for its energy. But before considering investing in the production of green electricity, it's necessary to know the ROI of such project, and therefore to characterize the energy demand of the terminal. This means knowing during a stopover the evolution of the energy balance of each machine used, or depending on the nature and quantity of goods, to matching energy production to demand in real time. Port of Bordeaux has developed the Port Community System VGCIP and initiated the creation of Economic Interest Group VG, which unites nearly 20 ports. IT developments were realized to integrate into VGCIP Pixel's results and data interfaces. The development of Pixel functionality within VGCIP anticipates the development of Pixel in other ports. Indeed, Port of Bordeaux, having chosen to integrate the result of various research and development programs into VGCIP to promote its development and energize the community. The first Pixel result was to study data energy to take the decision to launch the operation of production and supply of renewable energy. This decision was taken by the Port Supervisory Board in June 24. About 10 million euros for an installation of about 3 megawatts. This is a concrete use of Pixel data to go to an energetical self-sufficient port. Thus, from the point of view of the Port of Bordeaux, the interests of Pixel are multiple. Pixel has defined a common benchmark for ports, which will differentiate them from one another by publishing an overall score of their environmental performance. It will also allow them to monitor their own results and provide them with a powerful tool for decision support and communication. The detailed monitoring of energy demand linked to each stopover is essential information for reducing energy consumption by simulated impact of new equipment on pay or by exploring new sources of renewable energy. Port of Quebec, La Rochelle, and Bayonne are interested in Pixel, in particular by testing pay with their own data, and Modularity are interested by the Pixel concept. Thank you.
Fabrice, sorry to interrupt you. You have 5 more minutes. Thank you.
Okay, this is all for me for this presentation. Maybe there is some question.
Okay.
So, if we don't have any questions, thank you very much, Fabrice, for your presentation. We can move to the next presentation, which is the market potential, which the key exploitable results and the Pixel 4 products will be presented. And where Pixel has appeared so far in terms of dissemination will be explained by Mr. Joao Costa from XLab. So, Nacho, if you would like to present Joao, thank you very much.
Yes, of course. Well, we are flattered to present our innovation manager, Joao Costa, which have been doing a great work during these past few months towards driving Pixel results into actually some product. So presenting him, he's innovation manager both at XLab and our project, being a senior researcher also at the UNESCO. He has experience with project management, business development, and marketing processes in the research and development fields. And without anything else, Joao, the floor is yours.
Thank you very much, Nacho. First of all, I would like, while I'm trying to share my screen, I would like to thank you all for. I would like to thank the organization. Do you see my screen correctly? Correct? Yes.
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 Yeah. Okay. I would like to thank the organization, my colleagues, Leonidas, Nacho. I would like to thank the colleagues that had the presentations before of me, the great tour that Miguel gave us. It's nice. It's always nice to see the platform in its full power, in at least in great shape, and to see the leading one of the leading ports on our group actually on how they use the platform. This is very important because there's no solution without users, correct? This is a closure event. It's more like a celebration. I see a lot of known faces in this list. I'm very happy about it. Thanks for coming. I'm going to give a bit of a wrap on the present on what is the innovation or the key innovations on the project. Carlos in the beginning provided this very nice foundational preparation for what I'm going to say. So maybe I would like first to try and go back to this problem-driven product development that was key on our project since the beginning. This is very important, and we had several important problems that we wanted to deal with. One of them, as it was explained, the limitations that exist in the ports that are small and medium sized. They have their limited budget, infrastructure, staff, several other bottlenecks even before the COVID crisis, and they are asked often similar measures, similar aims to be reached as large ports that have more capacity. So in fact, being able to support the ecological transition and the digital transformation of this long tail of small and medium ports is fundamental, and being able to use this digital transformation guiding and support through the Pixel platform to also help on the cost of the ecological transition is very, very important as well. So besides the environmental performance tools that we provide in the end a bit more than that in this Green Deal era. And in fact, that's our main let's say our main line. The being able to greatly improve the environmental performance at the ports and terminals based on this IoT-driven technology that comes into the ports and terminals that will help them optimize the operations and with that reduce the costs. Now we're going to talk about the Port Environmental Index. My colleague Stjepan is going to be doing it greatly right after me. But I want to highlight that this was our flagship. Well, we heard this many times. Having IoT-driven environmental performance indicator that is able to look into several dimensions of this environmental performance, measure them and measure their reliability, being able to compare with the progress of the port and at several times. This is very, very important, and especially very important for those that have more difficulties on doing so. But the Port Environmental Index is not the only asset, the only important thing that Pixel brings. And in fact, to have the Port Environmental Index, we arrived to a few other aspects or technologies that in a way can be distinguished from the Port Environmental Index and have a very important impact on their own. Maybe we can start with having a strong and robust and flexible big data engine, which is the platform in its modularity, in its connectivity, in the way that it's using the data agents for the acquisition of data at the port for the different sensors based on the well-established Firewall technology that we have seen that Miguel was showing. This is very strong, and because of that we are able to bring to all size ports some sort of feeling of a digital twin approach. The port activity scenario, which allows for modules, for environmental model and simulation, particularly in energy efficiency, environmental pollution, and also the COVID-19 simulation. And this is very important. There are very important trends in the maritime industry, but also there is quite something that can be connected to it. And of course, last but definitely not least, seeing the powerful algorithms, artificial intelligence algorithms that will help us forecast on the roads at sea the operations of the port and the operations that relate with the port, and in fact that also relates with the port-city relationship in some way. And so maybe starting with those, we we provided, we put quite some effort on this meaningfulness, on having technologies that can be seen, can be analyzed, and can be and can be useful both in at sea and on the forecast that we were discussing on the road traffic. The possibility of going forward and being able to prepare what if scenarios for better planning in terms of environmental pollution, in terms of energy efficient balance, but also being able to or on COVID regulations, but also being able to add new computational models in some sort of way that fit the needs of the ports that we are talking with. And having a dashboard, having a platform that is easy to manage by everyone at the port, or at least that can fit this this learning curve that the digital transformation will imply in some sense in the maritime industry, but smooth and being able to have control and understanding of what's going on and what's being worked with. Now we were asking about the expectations of of many ports, terminals, inside and outside of Pixel, obviously, on the sense of how they want to, if they want to use, implement, or even buy based Pixel, based on the on aspects of the usability, comprehensiveness, sensibility to being specific, being fair outside sports, being able to monitor progress and position, but also we wanted to understand what are the innovations that we were proposing, even not being able to be tested at the time, and if we could be and how they interesting they were. And obviously Port Environmental Index is number one, but energy production model is also important. Traffic predictive algorithms are also quite important in what regards actually having the potential of buying it. Environmental pollution models are not yet for the buying, but definitely many would want to have the implementation of those. Being easy to use and integrate are important things. Being comprehensive is definitely fundamental. But we're also interested on being able to monitor progress and positioning. Now, we came to a way of delivering the Pixel technology, or several ways of delivering the Pixel technology that privilege the Port Environmental Index, because the Port Environmental Index is what we with Pixel want to set as an industry standard. So we would have, aside from what will be fully available and documented in the open repositories, the possibility of installing the basic functionality with having Port Environmental Index working on premises, obviously having a bigger option, a bigger full option, so Server Gold, and then we are working on the proposition of having a software as a service license, where a basic license fits the Port Environmental Index, and then having a bit more that would be able to, with that cloud version, be able to access energy focus or environmental pollution focus, which are those two that we felt that would be more they're more relevant, or two of the main focuses in right now. Now, looking at the competitors landscape, obviously, we are having in a single window of Pixel a lot of different areas. And what happens? What we looked into several general purpose solutions that are in the maritime industry, for example, SAP Cloud, IBM Cloud, and so on. Specific. More specific solutions like Arena and SmartPort, and others even we looked a bit also into port community systems that would want to offer or that are trying to upgrade their offers to differentiate, and the market is still quite it's fastly going forward, the environmental performance, but it's still very much tied to this technical and digital optimization of operations analysis and preparation. So it has not yet passed on to a more complete and mature level, so where maybe Pixel can have some advantage there. We are lucky to have next by our side a series of advisory board members of great importance that guide us through this journey. And highlight the importance of what we are believing to be the contribution to a bigger, at least European, answer to environmental performance improvement in the maritime industry. And we have an inspiring team that made it all possible with very engaging people at ports and at most of the different areas of expertise, from pure technological development like ProDevelop, XLabs, UPV, CATI, NCL, Orange. Orange was very, very fundamental as well, especially even more on the contribution to standards. Having CertNext was key, guiding us with people also, and the faculty of Rijeka. That defined and designed this port environmental index concept and science behind with the environmental KPIs that Creo Ocean gave good contribution to.
Good morning.
It is It is my it's a pleasure to deliver this this innovation and to be in, and I'm open to any questions, clarifications as always, either here or through contacts. Thank you.
Thank you, Joao. Actually, there is one question again by Mr. Bresselier regarding the difference between the software as a service and the on-price installation. Why is this price difference between those two?
The software as a service and on-premise. Okay, so on-premise is the typical, or It's a bit more than the typical business model of consulting over open source. We go, maybe I'll share the screen. We go and we install the technology, give a few hours of training, and provide what is needed. Here it is, and provide what is needed to kickstart and have the Pixel technology running on your servers. We can have the basic version or the high-end version. Now, the idea of having the software as a service is a possibility of actually having this offer with some configuration, but always updated and having a lot lighter versions that would be that we would be able to suffice more people. So as you see, on premises would be maybe more difficult to scale. If and hoping that there is a mainstream adoption of pay and of Pixel, and that pay becomes industry standard at some point. So these are all things that we are trying to consider. The on-premise is already available and it's already running and it's already happening. The software as a service is something that we want to provide as an enrichment of this business development over the Pixel technology. Did I answer the question?
Yes, thank you, Joao. It's very interesting. I don't think it will be an option in the future. It will be an obligation in the future. See what's going on with the Green Deal and with the European Green Taxonomy, which is very strong, pointing to compulsory reporting on these kind of issues. So it's very good. Thank you.
Yeah, very. It's strongly going on that direction and fastly going in that direction. So keeping just on-premise solution would be dangerous because it would be maybe it would be hard to scale so fast. Yeah, thank you. Any more questions?
Yes, actually there is one more question by Ms. Cristina Campos. If there is a possible future integration of safety at work or at premises in Pixel.
That's a very good question. That's a very good question. This obviously would be something that we would have to analyze. One of the things we've been trying to understand, first obviously by our early adopters, but to also with other parts, what would be new models that we would include on the Pixel platform, and maybe there we have when we were developing the COVID-19 pilot that we'll see maybe later on. I was thinking about that security at work topic that's very important, and it's and is one of the things that could come up as new as a new model into the platform. It depends on the data that is being collected for that effect. How is it being collected, and if it makes sense to be something that it's integrated on this context of Pixel or not. But I think it is. And it could give definitely an important new dimension to Pixel, and obviously be of much interest to many other parts. Thank you. Did I answer?
I think it is answered very well. Thank you very much, Joao. Now we move up to the next chapter of this of our agenda, which is related to our external keynote speakers. The first presentation will be looking for the future, the Pixel's role in governance and the sustainability plan. It will narrate the Pixel's perspective for governance-oriented entities, ports and cities, and will be presented by Mr. Jose Sanchez from the network of the port cities, and Mr. Jose Sanchez will be presented by Nacho. Thank you very much.
Thank you, Leonidas. Thank you, Joao, for your presentation before. And let me, in advance, thank all the external keynote speakers that will be part of the second block of the session today, which have been most kind for being present and being able to relate their experience with Pixel, starting with Jose Sanchez, which is an international project manager in AI VP. I hope I spelled it correctly, which is an NGO that creates a network of port cities around the world. And he is responsible for the development of their AVP Agenda 2030 and co-manages the Port Center Network and the Experts Network and coordinates the content of the port city community and the environmental affairs of this organization. So I pass you the floor. Jose, thank you in advance for your presentation.
Thank you, Nacho, for your kind introduction. I'm going to share my screen, first of all. Please confirm if you're seeing it. Can you please confirm that is showing?
Yes, we can see.
Yes, Jose, it's showing.
Okay, great. Well, like I said, first of all, thank you very much for inviting us for this closure moment for the Pixel port. I think in normal conditions we would be right now, perhaps after a coffee break, sharing a cup of coffee and talking about networking, talking about many other things, and would be definitely much more pleasant. Unfortunately, the conditions are what they are. I hope that in the future we'll get a chance to meet in different network or associated with other projects and so on. It has been a real pleasure for us to be involved in this in Pixel port as from our position in the advisory board, providing some feedback and mostly learning about this new fascinating tool that you have been developing in the past year. We were only in the, say, second half of the project, but it was quite good for us to follow, and we are excited about what is coming after this. In the presentation, I think we only have 8 to 10 minutes, as Nacho told us, so I'm just going to quickly justify why we have been involved in the project. Some quick conclusions or just one thought that I would like to share, and a small glance on future cooperation with what is going to emerge from the project. First of all, as it was said, AVP is the worldwide network of port cities, been already involved in several presentations with many members of the audience, so I don't think there is any need to explore any further, to explain more, but happy to later answer to any questions in emails about what we do. What is relevant and what was the initial connection point, I would say, was the AVP Agenda 2030 that we presented in 2018. This is something, and also our work with other projects, the European project of the same family, we could say so. And I'm not going to explain detail, I already presented, going to focus on the specific connections that we saw with the agenda that we launched and the Pixel port tools that have been developed in the past 3 years. The AVP agenda is, it was a work done along with our members and our experts, and the goal was to adapt the famous SDGs, the Sustainable Development Agenda of the United Nations, to the context of ports and cities. Many ports worldwide are integrating the SDGs in the strategic plans, in visions, in master plans, and so on. We just wanted to provide a new complementary angles and make it more explicit on how the different actions that are taken into this relationship, and the ports relationship, can be also connected to the global quest for sustainable development. We identified these 10 goals, but I think and in each one of them we identified also more concrete measures. Without entering into much detail, and I already presented this in other shared in other events, I think from Pixel or from the European projects. But very quickly, it's important, I think, to see the clear connection that were between these different sub-goals. With Pixel Port, it's clear that we see crossovers and direct applications of the Pixel tools related to the energy transition, circular economy, and health and life quality. For example, in the energy transition, we see that Pixel can definitely contribute to identify the potential synergies and help to develop a better management system of the existing natural resources. As it was said in the pitch by Bordeaux and what has been already discussed globally, we are not in the right path for the moment, so we need to change several things on the way we do things. And Pixel, we believe that Pixel can help in this particular goal. And of course, it's about as well in this goal, in the goal 2, about the transition circular economy, about the production and management of carbon neutral and renewable energies. And again, we look at this always from the point of view of connecting port and city. As we will explain later, this has to be, I would say, one of the main carry-home messages of the project, or at least from our perspective of the project. Another key goal for the ABP agenda relevant for Pixel is obviously sustainable mobility. We have seen in many places, many port cities around the globe, that mobility remains a significant challenge. We know that port cause traffic issues in many cities and regions. Definitely, we see that the Pixel Port tools that they have been explained, they can help to reduce these negative impacts and develop joint collaborative systems, both for planning but also for management of this traffic. Further on, regarding goal 9 about the health and life quality of the citizens, here is probably when it's a bit even more transparent and explicit. We in AVP, we identified as one of the priorities for this particular goal to allow independent, transparent measurements of all environmental, sorry for the background noise, of all the different environmental indicators of air quality, water quality, sound, and light pollution. And this, of course, is also going to help to promote and support the development of greener port facilities. As you may have seen, and you probably identify several of the projects that are in the images, they refer to large-scale ports, particularly European ports, that have been working on innovative measures and innovative technologies already for some years. We believe, as it was in the mission of Pixel Port, that these tools are going to be particularly relevant for small and medium-sized ports. We recently, in just last week, I got the chance to moderate one session on port green technology, conference on new solutions for green ports. And in the session, we had the Port of London Authority, that is member of AVP, and 2 other ports, including, for example, the Port of Aveiro, that is a port in Portugal. And one of the key issues was exactly the challenges that small and medium ports may find in their way to, for example, into the energy transition and to become carbon neutral ports. And we see that new tools are indeed necessary to balance and to help these small and medium ports to implement systems that can help them achieve their goals. And it's interesting because they are these ports, they are not less ambitious, they are not less aware of the challenges that exist worldwide. They are not less aware of the role that they play in the regional logistic chains, but it is very clear that the resources are quite different. So for that, I really think that Pixelport has the tools of Pixel have a good future in the coming years. Further on, one key idea that we defend in AAVP is the co-construction with the citizens, and this is framed in the renewed governance of port cities, goal 4 of our AAVP Agenda 2030. And here is where we believe that the tools that have been developed in Pixel can play an even bigger role. One of the main demands that we see of local societies, of group of citizens living in port cities, is for transparency, and to have a long-term consultation and agreement with different actors and the city and the citizens that live in this area. So this is of course connected to transparent assessment and monitoring that we identified in different goals, but here is even far more important. People demand transparency. People want to know what is happening in the port. They want to have access to the information. They want to have access to information that it's manageable, readable, also by non-experts. And here's where we believe that particularly the PEI can PEI, if I correctly pronounce it, PEI, can really help to establish a renewed dialogue with the citizens, play a big role in the port city vision, and establish new communication channels or new platforms to share this information. Now, regarding the port city vision, which is another key idea that we have also defended, we believe that it's important to have a shared port city vision between the different stakeholders. This is what a shared port city vision could look like, focusing something coming from 15, 20 years ago, focusing exclusively or mostly on the physical and the physical environment, on the territory that port and city actors are sharing. This is from the city of Marseille. What we do think is that looking at the future, we should also talk about smart port city vision or smart port city pact, in order to also structure the exchanges and the solutions that need to emerge to address the challenges that are going to affect this territory. Challenges that I already highlighted in the past slides about mobility, monitoring, supply, better cooperation for supply and demand of different services, for example, related to energy, to predict the externalities, and why not also include issues such as alert systems for weather events or tides and so on, and of course all connected to increased transparency. We think that this is should be one of the carry-home messages from Pixel in terms of, okay, there are already the tools to set the base for these smart port city visions, and we do see several some cases that are already developing, such as Le Havre, and it could be a very good base for future European project applications. Now, regarding our interaction with Pixel, we have discussed already informally with several members of the team. We are happy to see that the project and the people behind the project have decided to settle and to prepare an association that will take the form of an NGO, and we will be glad to continue this cooperation eventually with a renewed MOU or the official framework that we consider appropriate. Of course, we will continue cooperating to provide feedback for further development, to see what are the new tools, perhaps the issue of security that was mentioned before, or other issues that affect the port-city relationship. We will be happy also to keep on giving visibility to the work that is being done by Pixel as a new association. Why not discuss potential agreements for AAVP members, and more particularly to work together in an assessment tool for the ABP Agenda 2030. This is something that we discussed already in the past. We believe it's something that ABP has been working. The COVID affected us because we have to restructure our resources towards more urgent issues. We are getting back on this, and we're really looking forward in the next years to launch this. And these, of course, will help us provide a quantitative evaluation of the environmental impact, which is something that, as was said before, it's very relevant. So I conclude with that. Thank you very much for your attention in these few minutes, and mostly thank you for including us in the discussion developing the past 3 years, year and a half that we were more directly involved. Thank you.
Thank you very much for this presentation. It is always very interesting to see the views of people external from Pixel. And now we are moving on to see presentations from other keynote speakers. First of all, it will be from Docs the Future regarding the Pixel adoption in the research coordination support action community. I remind to the audience that Docs the Future is Horizon 2020 coordination support action project aimed to define the vision for the ports of the future in 2030. The presentation will be done by Mr. Alexio Pico, and Nacho will present Mr. Pico to us.
Yes, thank you, Leonidas, and also thank you, Jose, for your presentation. And now it's the turn for Alexio Pico, which to whom I strongly thank for his availability to be here today. He's a very well-known person in the maritime sector innovation field, so we are always glad to count with him in this kind of events. In case that you don't know him, Alexio is one of the managing directors at Circle Group, member of the board and Info.era in Progetto Adel, and president of Magellan Circle, and director also of the Connecting European Union Business Unit. He's very experienced with working in policymakers, academics, third parties, research projects, coordination and support actions, especially in passengers and freight transport innovation. So the floor is yours, Alexio. Thank you for your presentation.
Thanks so much, Nacho, and thanks so much, Leonidas. Good morning, ladies and gentlemen. It's really a pleasure for me to be here because since the very beginning of our Port of the Future coordinated action named Docs the Future, we have been working together with the 3 research and innovation actions, being Pixel one of those. And so I'm very happy to be part now of this final conference. So do you see my screen?
Yes, Alexio, go ahead.
Okay, fine.
Yes.
I put in presentation mode and it should be okay. So my task today is to explain a little bit what was coming out of Docs the Future, and that is a spin-off in a way, as an exploited result. We created from Docs the Future a network of excellence of ports that is named the same name of the project to maintain a certain logic. So we have now a network of excellence that is called Docs the Future. And the idea is to briefly present you the aim of the network, what we are doing, what we are aiming to achieve, and things like that. So this is the agenda, the membership, what the network offers, what the network asks to its members, and also activities and idea for the future. The idea was, it's very simple. Ports are really a very, very, could be a very innovative living lab in a way, and Pixel is a further demonstration of this. And so we decided to try to stay closer to a number of ports after the Docs the Future project, and not only to exploit some of the tools we developed within the project, but also to try to develop further projects. And this is still the idea. And in that respect, I'm very happy to be here to see the results from Pixel, because I see a great potential to be exploited in many ports. Specifically, I was impressed by some of them, and I really like, for instance, the Port Environmental Index that I see as an incredible tool that can be, developed and shaped a little bit differently in different ports, but it could have a number of exploitation in many areas. So the idea is to bring ports together to work around to work around the main points that we are discussing also today, from city-port relation that have just been so well presented by José, but also multimodal transport, digitalization, and specifically, I think Pixel was a little bit anticipating the trend, because we are totally now living in the energy transition and environmental and energy transition era, in which ports are becoming energy hubs, not only connectivity hubs as they were. And for this, the tools that Pixel developed are even more important in terms of energy management, potential of alternative fuels, and environmental impacts of the supply chain, environmental impacts of the port operation. So these are the topics of the network. So and this is perfect to have the Pixel result presented today. These are the membership. Currently, we have 21 ports, considering that 21 ports, if I'm not wrong. And we have also, and let's say, as a member, the Ville Port. So José is one of our members. And this is what the representation is more or less spread all around Europe, from the north to south, east to west, and also representing the different sea basins. So it's a very good achievement, considering that when we started the idea at the end of Doxa Future, of course, we were thinking also to have some physical gathering. That was almost impossible, because we launched the network exactly at the beginning of the COVID era. And that means that nevertheless, we had a number of meetings, and we are working with those ports to develop new things, presenting new things, and working with them. What we offer news that are related to on innovation, on all those fields that are in our portal doxafuture.eu. It's really a little bit more than, let's say, bi-monthly webinar and meetings, because in reality we have more or less one meeting per month in which we present some very interesting results or innovation that the ports can bring, or also present new programs. For instance, we are now working on the new Connecting Euro Facility 2 call that has been very recently launched, in terms of what port can do, also about motorways of the sea. That is a topic that I'm quite well working with. And so more than that, we offer also some specific events that from next year we think that we could organize physical events in synergy with other sector events. To give you an example, the first event was meant to be at the time of the 20 days last April. And so the idea next year, it will be with some more physical meeting coming. Once or twice a year, we will have some physical meetings of the network events in parallel with those sector events. We offer also business-to-business facilitation, because, for instance, when there is a tool that we judge innovative, we present the tool to ports, and it could be also a private company that present that if we judge that this is something suitable for innovative projects. And then, of course, this could lead to further engagement between ports and innovation providers. We have also a number of experts that we selected already during the project, and they participated in a number of events. They are nearly 30 to 50 experts that they could be available on request if we call them for very specific thing. And with some of them we have been working and we are working in several projects around Europe. And also we have these digital and physical gatherings. The first one, we have a physical one in a couple of days in La Spezia. We see how many they come together in parallel of one of the first physical event it is organized nowadays, that is called Sea Future, in which we have on next Thursday in 2 days a conference organized by the Circle Group exactly on the topics I discussed before. What we ask is not that much. The network is, in a way, it's the willingness to cooperate, the willingness to do projects together and to be together, because the network is for free. It's still, you don't need the port, they don't need to pay anything for that. They need to appoint some contact persons in the organization, depending the area of interest. Of course, they are pushed in a way, chased to exchange information and best practices, to promote the network through their communication tools. For instance, including the banner on the website, and also sending out a press release when they join the network. So but you see, these are not very huge things. What we ask is the willingness to cooperate. And as far as I see this willingness there, and I'm sure that we will continue to carry on like that. As mentioned, we have the upcoming one, digital and physical, next week, in next Thursday, the 1st of October. That is during our convention See Future. And of course, we really think that for the near future, Pixel could be invited in a specific session, because most of the tools you presented, and okay, again, in my mind, the Port Environmental Index is one that is key, because it's very also easy to be understood. Others, they need a little bit more technical background, but the Port Environmental Index is something, you know, that on the spot you see quite well. So this is important. And I take also the opportunity to thank you all the supporting partners of this network of excellence, being the partners of the Docs the Future project. There are some of them, specifically Joris and Peter, that asked some questions from Port Expertise, that they contributed to the development and to the network, to have the network of excellence as it is, together with the other members of the consortium, being ISL in Bremer, the University of Genoa, and Magellan in Portugal. So this is it. I think if you need more information, of course, you can drop me a line. To me or to the communication manager, Valeria, my colleague. And of course, we would be happy to have Pixel to present results soon. And so I will get back to Leonidas and Nacho to have Pixel, and the other partners to have this. And I hope that this was interesting enough to have some more members to come in the network. Thanks a lot. Thanks again, Nacho and Leonidas, to have me today.
Thank you, Alexio, very much for the presentation. Moving on is the next presentation, which is one of the sistering projects of Pixel under the umbrella of Docs the Future, and it is the Coriolis presentation with regards to Pixel, and will be done by Mr. Yannis Kanellopoulos. Nacho, if you could present Mr. Kanellopoulos, thank you very much.
Yes, of course. Thank you very much, Alexio, for your very interesting presentation, as always. And now I would like to welcome and thank in advance Yannis Kanellopoulos, which is a member of the company ICCS, which actually is an institute that has been coordinating Coriolis project that ended some months ago. And he is the unit leader in the institute for the logistics and maritime unit. And he has more than 20 years of experience in systems analysis, software engineering, and data networking, and has also a special experience in the maritime ports field. So the floor is yours, Yannis. Thank you in advance.
Thank you very much, Nacho. Let me share my screen. Okay, are you able to see my presentation?
Yes, very good, Yannis.
Thank you very much. So I'm here to present, as you already said, a sister project of Pixel, which was funded under the same R&I action. It's the Coriolis project under the title of Sustainable Innovative Footprints for Future in Ports. And in Coriolis, what we did was to gather as many of the big ports of Europe and try to build tools that were of value to them. The project received about 5 million grant and lasted 36 months. We were quite lucky, and it was very hard work to complete it on time, even under the COVID pandemic. And we were able to include 17 partners from 9 European countries, among them 4 research institutes, 5 port operators, 4 industries, 3 SMEs, and 1 ITS association. The demonstration took place in 5 European port cities, including 3 of the top 10 ports in Europe. The 5 ports that were included was the port of Antwerp in Belgium, the Piraeus port in Greece, the Valencia port in Spain, Livorno port in Italy, and the Haminakotka port in Finland. Coriolis tried to develop a number of tools that were able to act either independently or within the platform, local platforms that were built in the ports, and this is one of their major advantages, that they're easily transferable and they can easily be integrated into any port that wishes to take advantage of them. In brief, I'm going to show you what are the innovations that we managed to complete within the scope of Coriolis, and in the next slides I will be presenting the most important of them that are currently being used by ports and are being under further development for business purposes. So one of them was the Port of the Future Serious game, which is a simulation tool for decision making and takes into consideration future actions that ports and local authorities and stakeholders can carry out, and manages to predict what are going to be the effects of these actions in the development of the port and the city in general. So using this tool, we can have an accurate prediction of what are going to be the developments and be able to apply corrective actions in order to set up a plan that's going to be best not only for the port development but also for the city and whatever the stakeholders of the port wish. Next one was the just-in-time rail shuttle service, which is actually a feasibility study of what can be the benefits by having a rail available at the time of discharging the containers in a container terminal from the vessels and be able to load them directly on a shuttle service, on a rail shuttle service. And we showed up that there are considerable financial benefits that are coming out of it, even though the planning was a challenge, but still it can be achievable. The predictor for asset management was a machine learning tool that was based on just-in-time inventory in order to predict what are going to be the breakdowns in yard equipment. Specifically, we used 3 years of historic data from the fleet of trucks of the Piraeus port in order to be able to predict what are going to be the breakdowns and the number of spare parts that are going to be needed in order to fix the breakdowns in over a prolonged period that it's under the control of the user. The predictor tool managed to reach the accuracy of about 87% in terms of breakdowns and 85% in terms of the number of spare parts that were needed in order to fix the breakdown. Overall, it has managed to save about 7% in financial terms in spare parts, and it's being currently deployed under the Hellenic Port Community System that is hosted in Piraeus in order to be able and available to the rest of the ports in Greece that wish to be part of it. The Cargo Flow Optimizer is an optimization tool that is handling the multimodal transport from the sea to inland using road, rail and inland waterways, which I'm going to explain a bit more in the next slides. The track appointment system is a reservation system that includes real-time traffic data that calculates the ETA, the estimated time of arrival of trucks into ports, and was applied in the port of Valencia and the port of Haminakotka. I'm also going to present it in the next slides. The brokerage platform is a platform that allows the exchange of assets within the ports among stakeholders and terminal operators that allows for the optimal use of assets and minimizing the idle times of them. It also has the opportunity to be used also for personnel exchange, man hours that are charged between different stakeholders in case the local legislation allows for it. And the port mode was a planning tool, an optimization planning tool that was used in order to determine what is the best yard layout based on historical data and the moves that are taking place using the berthing places of vessels and the location of containers in the container yards. The RT port was the first 5G installation in European ports. It was carried out in the port of Livorno and was used in order to be able to support smart operations for bulk cargo operations within a port by measuring the volume of the cargo and be able to select the best position of it in the yard. And finally, we had also an innovation incubator where we had a hackathon in order to determine what are the best solutions to develop in the Port of Valencia, and also a feasibility study that was the Green Cookbook that allowed for the energy assessment of the Port of Piraeus and the ability to determine what is the best use of renewable energy sources and what part of the current energy needs can be replaced by the use of renewable energy sources in the Port of Piraeus. Plus, the feasibility study took also under its consideration the cost that was involved and the return on investment for any investment that was done on renewable energy sources. Now I'm going to explain a little bit more on these innovations. First of all, the cargo flow optimizer that took place in the Antwerp port. The tool takes input from the terminal in order to find out what are the number of containers arriving and what are the available inland mode transports that can be used. And the prediction was carried out in order to determine what were the alternatives that are available, and all of them had some parameters on it in order to allow the selection from the end user. These parameters included the total distance that was supposed to be covered, the time in terms of turnaround time for the delivery of the container, the cost for the specific route, and the CO2 emissions that were involved by selecting the available modes. This way, the end users can select what is the best route that they need to follow depending on their needs, whether this is time or whether this is cost or environmental parameters. And this way we can minimize the container waiting times in the port, that it is a very important factor for the efficiency of ports, as well as the cost and the total turnaround times for the delivery of cargo. The Coriolis Artiport included the installation of 5G equipment in the port of Livorno, along with a set of cameras, LiDAR cameras and other sensors that were allowing to take real-time control of operations and collect data both from the vehicles that were running around the yard, as well as the various cameras and sensors that were placed on standard points. By performing online analytic and processing, we managed to reach a high level of automation in the general cargo management process and be able to select the best places to store bulk cargo. To increase the visibility of the cargo, that for bulk cargo is quite important and not readily available as it is in container terminals, and to be able to reduce the number of moves required and the total mileage of the yard equipment in order to store the cargo in the yard. On top of that, we had safety improvement because we no more needed human presence in most of the points in the yard with the development of these tools, and thus accidents were minimized there because we had no presence over there. The track appointment system is another tool. Its main innovation was the inclusion of an ETA.
In Marlines proprio perché si è rotto le balle di una gestione un po' così.
Okay, so I thought there was...
sorry, I will fix this.
Okay. So for the track appointment system, the main innovation was the inclusion of an ETA and rescheduling. There was a mobile application that was installed in the smartphones of drivers and were able to predict on time what is going to be the arrival. And this could lead to the reduction of gate queues and the reduction of total mileage run by the trucks. The track appointment system was demonstrations were done in the port of Valencia and the port of Kamina-Kotka. It is currently being deployed in all 5 terminals of the port of Kamina-Kotka.
Sorry for interrupting, John. It's 2 minutes and we will need to shift to the next speaker. Thanks.
So I'm finishing, I'm summing up. Thank you very much, Nacho. Now, for the Coriolis predictor, the asset management, as I already told you, is a predictor tool that takes into consideration historical data and real-time data coming up from the inventory and the telemetry data from the tracks in order to predict what are going to be the breakdowns and to be able to reduce the total inventory needed, as well as increase the efficiency and the availability of yard equipment. The Port of the Future is a serious game that makes use of a number of cards in order to that each one of them relate to a specific event or a specific development of the port. And being able to select specific cards which relate to an action, we are able to calculate KPIs related to the people, the planet, and the profit of the community, and also have a pictorial representation of what is going to be the development of the port and what corrective actions we need to make. So the expected impact of Coriolis in general is to embrace circular economy models into the port strategy and operations that traditionally have not been included, to improve the operational efficiency and optimize the yard capacity and streamline the cargo flows without infrastructure investments. That's quite important for ports. To reduce the total environmental footprint by associated intermodal connections and including all 3 transport modes and shifting from road to lane and inland waterways, and to enable the port to take informed medium and long-term strategic decisions that become an innovation hub for the local workplace. Here you can find the social media of the Coriolis. The project is finished, but we're still active on supporting it and extending it. There are a number of innovations that are taking up to the market, and we will be glad to assist you or give you any information that you would like from us. Thank you very much, Nacho.
Thank you, Yanni, for your presentation. Moving on to the next Pixel sistering project, which is the Port Forward, and the presentation will be done by Mr. Olaf Penike.
Yes, thank you, Leonidas. Thank you, Yanis, for the presentation. I will just now introduce the last speaker in this block of external speakers. Afterwards, we will move towards a little bit more, move the session with some technical demonstrations. And to conclude, I would like to present Mr. Olaf Penike, the research manager at Fraunhofer IFF since 2009, where he specializes in digital technologies in production and logistics processes. And Mr. Penike has been coordinating Port Forward since early 2020, and we have had a very good shared experience. So I would like to thank him in advance to be here presenting our interaction. Thank you, Olaf, and I would like to also ask you to try to be as brief as possible, so not to be as behind the schedule as we are at this point. Thank you.
Okay, yeah. Hello to everybody also from my side. Thanks very much for the introduction, and as we now have to speed up, I try to present to you the project Port Forward as brief as possible. But I think, of course, some details is necessary because I just realized with the presentation of Janice that there are maybe some approaches to have further collaboration on certain topics, and as well, of course, with Pixel. But to give you first a brief overview on the Port Forward project. So it is the 3rd project in this Horizon 2020 network of ports of the future. In Port Forward, we have 13 project partners in total. So we have got 5 ports. One specialty is that we have also one inland port on board with the port of Magdeburg. And besides that, all ports are also small and medium-sized ports, so a bit similar to the Pixel project. We have a project duration now of 4 years. So we finally decided, because of some delays due to the COVID pandemic, that we needed to extend the project for 6 months, so we will end up at the end of June next year. And of course, we also hope that we will be able to organize some physical meetings as well. Very briefly looking at what PortForward does. So we have specific use cases based on the requirements of single port, but the overall approach of PortForward is to develop a platform which can run several services, and which is thought that the ports should be able to customize different services and also aggregate those services individually. To go through this scheme very quickly, on the left side you've got input of data, which may be from legacy systems, but also from new sensor technology, new devices. So also IoT and other sensor technologies play an important role in our project. Then, of course, we always have some kind of data transmission, some communication, and then part of the PortForward platform is an IoT stack. So it's a middleware component, which is harmonizing data from different sources and provides those data to the cloud platform where individual services are running. And those services then can also interact with each other, so that a single port can say, okay, for me, those and those services are relevant. And those services can then interact and also be visualized in an integrated way in the user interface. So there we have the so-called PortForward dashboard as a central user interface, but we are also working on other user interfaces based on augmented reality, which I will show later on for a specific use case. And also for a virtual, so-called virtual twin, so for a complete 3D model of a port as a user interface. So in total, we've got 10 use cases in the project, which are tested and implemented at the 5 ports that we have on board. So we are testing our use cases in the inland port of Magdeburg, at the port of Vigo, Port of Baleares, also Livorno on board in our project, and the port of Naples. And last but not least, the port of Kristiansand has got more like an advisory role and also is a potential replicating port. To give you a brief idea what the different use cases are about in our project, so we just have now a selection of 5 of the use cases. So for each port, 1 of the major use cases, just to also show you the variety of topics that we aim at in our use cases. So at Port of Baleares, 1 of the 3 use cases is focusing on on a RoRo terminal and the storage optimization. So it begins with a tracking of MAFIs also in the RoRo terminal to optimize the traffics, and then of course the storage optimization for the RoRo shipping or the RoRo vessels is an important part of the use case. This use case is also carried out in cooperation with a line of Trans-Mediterranean. I think probably one of the most prominent use cases in our project is the so-called Green Yacht Scheduler at the port of Vigo. So the idea here is in a container terminal to optimize the operation, not only the classical way based on time and money, but also looking at the environmental impact, so that different operations like housekeeping, container positioning, and yard crane scheduling can be also optimized with regards to the environmental impact. So it is basically some kind of calculator which is also connected to the terminal operating system at Vigo port, and with the task that has to be carried out, this optimizer is providing different options for the operational personnel to actually choose when time is restricted, for example, to go for the time-efficient solution, but also always offering a more environmental feasible option. Then a use case at the Port of Naples is the so-called Port Authority dashboard, which is also part of the Port Forward dashboard. And this is basically collecting data from several legacy systems and is calculating different kind of performance indicators in 5 different pillars. So also here the environmental aspects form one specific pillar for indicators. So this is a tool primarily focusing on port authorities, as the name already says. Then we have 2 use cases at the Port of Livorno, which are using augmented reality technology. So here we have the support, the remote support of terminal workers, for example, for container inspection, that they receive specific information on single containers and also can interact with other personnel which are doing the yard planning, for example, or also with other externals that can be connected remotely to the terminal workers. And last but not least, at the Port of Magdeburg, we have got the specific topic of the virtual twin. So the complete Port of Magdeburg is also available as a dynamic 3D model. And one of the use cases there is what we call the dynamic storage space monitoring. The idea behind that is that the small or relatively small port uses its terminals in multi-purpose, so it's not just a dedicated container terminal, but this specific terminal is used for container, for other bulk materials, machinery stuff. So it is quite complex to have an efficient yard management, and here that's the similarity with the presentation from Janice. We also are using LiDAR technology here to automatically detect the occupancy of the storage areas, and we automatically integrate this into the 3D model to always have an updated overview on the availability of storage locations. Yeah. So last slide. When it comes to the exploitation of our approaches in the project, we basically have got 2 approaches. One approach is to exploit the overall Port Forward platform and also to open the platform to other services to be included. So this may be a good opportunity also to collaborate with the outcome of the Pixel and the Coriolis project, and we would be happy to further talk to you about this opportunity. And of course, let's say the traditional exploitation perspective is, of course, to individually exploit the single services in the different use cases and to replicate such solutions also to other ports. So yeah, here once more that we, of course, would like to talk with you also in the next future on possible collaboration when it comes to the exploitation of the results. So last slide, just also to give you an idea how you can reach me or also reach the project on the internet. And so far, thanks very much for the opportunity to give this presentation, to give you an overview on the Port Forward project. And I would be happy to further talk to you about collaboration possibilities. Thanks a lot.
Thank you very much, Olaf, for your presentation. We're moving on to the next chapter of this of our agenda, which is going to present the some technical things about the Pixel. And first of all, we're going to present our flagship product, which is the Port Environmental Index. The Port Environmental Index has been developed in Pixel, and Professor Traven's team has directed this effort. Unfortunately, Professor Traven was not able to join us today, but his collaborator, Mr. Stefan Plisic, is here, and together with Mr. Lacalle, they will present this very innovative product we are offering with Pixel.
Yes, thank you, Leonidas. Just before passing you the floor, Stepan, I would like to thank Olaf for his very good presentation, and also to introduce a little bit what this session will be. As it has been mentioned several times already during today's session and different events where Pixel has been presented, we do consider the Port Environmental Index as our flagship outcome, meaning that it's the most quote, innovative because it's a new or novel approach about quantifying in a single indicator what is the impact towards the environment from maritime port operations. And this session will be composed of two main parts. And my colleague Stepan Plisic will just present what the tool has been constructed and what's why it's meaningful and how it has been designed for the ports and the science behind it from the environmental and medical faculty from Rijeka's is where he comes from. And afterwards, I will step in presenting you a little bit tiny demonstration of how this Port Environmental Index tool could be devised as being working in a real port. Afterwards, we will be ready for answering any questions you may have, and also we will be able to share you how it actually works from web browser that a maritime port manager can deal with and can manage. So please go ahead, Stepan, with your first part.
Hello, everyone. Can you see my presentation?
Yes.
Yes.
Okay. So as Mr. Lacalle introduced me, my name is Stepan Plisic. I am a research assistant at Faculty of Medicine in Rijeka. Today, I will present you about the Port Environmental Index, shortly PEI, or PEI, as I will call it during the presentation. I have divided the presentation in two parts. The first one is a short overview of the Port Environmental Index for those of you that maybe have missed our last webinar. And after that, we will give you an example of PEI visualization. So let's start. So what is the PEI and why we have developed it? The main reason for the development was that the current methodologies they lack quantitative results. All of them are qualitative, and with qualitative assessment, it is harder to make some objective results that we can use to compare ports, or as you will see, what we can do when we have qualitative results. So we decided to create a composite that will be as objective as possible. And so we can use the PEI for two or three things. Two of the main objectives is that ports can track their evolution of their environmental impact. For example, they can follow year-by-year comparison. They can follow how their environmental impacts change during 1 year. For example, in which month is the pollution the worst. And also the other objective of the PEI was to enable the comparison between those ports. For example, if we have some qualitative methodology, it is impossible to compare two or more ports. But when we have numerical quantitative results, we can compare different ports, and ports can see where it stands in comparison with their, let's say, competitors. And consequently, from these two objectives, there is also a third use of the PEI. It is a decision-making tool. or tool that can help ports make decisions. As ports can track their environmental performance, and as they can compare performance to other ports, it is easier to them to see maybe their weak points and do something to improve them, or I don't know, they can maybe have in plan some other development, and they can see how it impacts their environmental performance. And so that's it about the objectives. Now a little bit about the index itself, how it's structured. We have divided the composite indicator into 3 sub-indices, or 4. The 3 main sub-indices are all divided considering the main source of the pollution. So we have ship environmental index, where the main source are ships in the port. We have terminal environmental index, where we have terminal operators as the main source. And we have port authority environmental index. In addition to these, we have one additional index that we have called all, or in the later terminology, we'll see also global environmental index. It encompasses those indicators that is very hard to differentiate between the sources, such as noise pollution or I don't know, odor pollution. And each of these environmental sub-indices have their relevant environmental aspects. For example, you can see, say, ship environmental index has air emission, waste emission, and wastewater emission is the same with terminal environmental index and port authority environmental index. And then each of these aspects is divided into indicators. For example, for air pollution, we have CO2, NOx, SOx, and similar stuff. For light monitoring, we have only one indicator, that is light. And for environmental noise levels, we have DEN level, LDEN level, and LNIght level. But not to go into too many details, all those sub-indices are calculated based on the values we have for each of indicators. So we have the results for each sub-indices, which are then aggregated into the final index, which is the pay. And now a little bit about the visualization, how it looks like. On the right side, you can see a number 0.44. It represents the current value of the pay in a port for which it was calculated. Or 0.4 means that that port was somewhere in the middle, as 0 is pretty much a terrible performance and 1 is a perfect environmental performance. This one stands in the middle. And on the left side, you can see a chart that shows how the environmental index changes throughout the year. For example, we can track the bold line is the port environmental index and the composite indicator, and the thinner lines all represents some of the sub-indices I have mentioned earlier. Also on the right side, you can see some percentage, 66.5% in this case. That is a reliability rating. Reliability rating, it shows us how far from the ideal data gathering methodology is the methodology that we are currently using for our environmental indicators. So, I know it sounds a little bit abstract when I say it like that, but for example, here we have a noise, which is one of the indicators. And the noise should be obtained by sensors in real time. But in case that we don't have sensors, that we don't have some periodical measurements, we can obtain some values from the relevant literature. And those approximations are pretty worst possible way to input the data, So the reliability rating would be very low, let's say 20% or something like that. On the contrary, if the ideal data acquisition method is sensor and we have working real-time sensor, the percentage would probably be close to 100%, if not 100%. Just one additional thing about the reliability rating, we have it in order to make pay more inclusive, because not all ports can include all the sensors, they can't afford it, so we enable the calculation even for ports that maybe can't afford this, but it is reflected in the lower reliability rating score. And when I am talking about the different ports, we can also see on the right side the comparison between ports and how it looks like. It is anonymous for all other ports. For example, if I work at the port, I know the ranking of my port and I see it compared with other ports, but I don't know which other ports are. In this example, the port that was that the pay was calculated for was ranked as the best performing ports in both 2019 and 20. And the other example ports, you can see at ports 2 and 3, they switch their rating. So the port can follow its rating relative to other ports using this table. And so I was talking about individual indicators, and here is the representation of those indicators. So in this case, green indicates ships, not the best performance, and red indicates terminals. Okay, and we can see that this port performs better in some, for example, ship-related issues, but worse in terminal and global indexes. Okay, so I was talking about the aggregation and normalization and all that about the sub-indices into a composite indicator. So here it's a little bit hard to show, but here is an example how it looks. Here you can see individual indicators that are combined into environmental aspects such as wastewater, air pollution, noise, etc., which are combined into the relevant sub-indices, which are then combined into pay. But important is that we can choose different methods. For example, here we have equal weighting method, we have hot deck imputation method, and we have distance to a reference normalization method. And those can be changed, and it reflects the pay value. But in this case, we have chosen this set of, let's say, normalization, weighting, and input methods. And finally, how does it look when the port wants to enter some data? Here is an example of waste production in a port. And you can see the form that a port employee can use to enter it. There is nothing extraordinarily complicated, but he needs to enter these numbers, and then those numbers will be calculated. With those numbers, the index would be calculated. And after everything is done, a pay report is created that can be downloaded, that presents all the relevant information for the pay calculation. So it has a calculation date, it has configurations, that is mostly the methods I was talking, like normalization method, weighting method, aggregation method, and so on. And finally, we have the values. So what these values represent? Pay value, it's the final value for whole port taken, as a whole. And the reliability rating, this is RR value. I have explained it earlier. And we also have pay sub-indices values. It's ship environmental index, terminal environmental index, and global environmental index. In this case, the port doesn't differentiate between terminal environmental index and port authority environmental index. That is only terminal environmental index, but we can see this port performs pretty good in ship environmental index, a little bit worse in terminal environmental index, and their weakest link is global environmental index, which in this case encompasses light and noise pollution. So it means that the port needs to improve most in this segment. Here we come to the decision-making tool that I was talking. And we also have a reliability rating for each of these sub-indices. And here also we can see that their technology is the best in ship and terminal environmental indexes and weaker in the global one. And so that's it from me. If there are any questions, I'm here to answer. If not, I will pass to my colleague, Ignacio.
Thank you very much, Stepan. As I am not seeing any hand raised, I will just proceed with mine. So if you allowed me just a second to share my screen, let me find this. Okay. Okay, are you seeing this?
Yes.
Okay, great, thank you. So after what my colleague Stepan has explained, I will just go very quickly through a tiny demonstration we have prepared for today, because although he has included relevant and say real screenshots from the functioning of this tool in the actual ports in our pilots, we have decided to bring you a bit of more in situ hands-on demonstration of how this could work with vessels in the port, etc. So just refreshing a bit what my colleague Stepan has said, I will not be here much longer, about the objective of the PI, which is quantifying the environmental performance at the port via a composite indicator, which is divided in sub-indexes categorized per type. As he has presented in Pixel, we defined air quality, wastewater, noise, light and odor categories, and different origins from the port, differentiated between the seaside part of the port relating to the vessels, the ships, the terminal operations part of the port, kind of in the middle, and finally the attributable impact associated to the port authority. So these kind of three origins of the impact in these 6 categories of environmental items or topics, let's say. And it highly relies on mathematical tools for normalization, aggregation, and weighting that have had a great statistical and mathematical and scientific studies during these almost 3.5 years that have driven us to select specific of those tools to actually implement this in the pilots. Also, all of this has been accompanied with a meaningful user experience, as the example of the screenshot that is being showed here, as my colleague Stefan has also shown. The technology behind PI is actually, well, Pixel. As we have been discussing today in several sessions, and thanks to my colleague Miguel Angel that has done a turnaround the platform, you have seen that we are hugely relying on Internet of Things techniques, such as having a central context broker in the data acquisition layer that concentrates information coming from different origins, meaning sensors, web URLs, APIs, even forms introduced manually, simulations, data from the literature, gathering everything on a single format using the Orion context broker from hardware that is afterwards stored in a persistence database based on the ELK stack, meaning Elasticsearch Logstash Kibana stack, for afterwards being used that long-term persistent information orchestrated via the operational tools that have been mentioned before to schedule the executing of this PI that, in essence, get the information that is centralized in this information hub has been coming from the sensors gathered through this acquisition layer, apply some mathematical operations upon this past data, because Port Environmental Index is a retrospective tool, meaning it provides information of the impact of the port towards the environment in a past period of time, for instance, last day, last week, or even last minute, last fortnight, last fortnight. So it can be modifiable, and we have developed in this late visualization of model execution, we have developed it as flexible and as modular as possible, so that although we have for pixel pilots selected specific mathematical approaches, mathematical operations, specific normalizations methods, a specific way of calculating the reliability rating, etc., we have delivered the tool as abstracted as possible, so in for further implementations of it, these can be changeable and selectable. And one of the potential usages of this, as Jose Sanchez has explained before, would be to modify it, improve it to meet certain expectations, to assess, for instance, how one port is sticking to the Agenda 2030 of IBP or other, say, certifications or programs promoted by a specific entity. So, although it has been tailored for our pilots, it has been constructed as modularly as possible to be used in further contexts, always with our scientific studies behind. So, after this technical explanation has been done, let me just introduce you what you are about to see in 1 minute. For letting you know in a scale model way how this could work, we devised this kind of tiny structure that would simulate what actual port might have on their premises. To simulate a real context and a real scenario environment in which one port would be able to, through IoT sensors, measure different parts of the environment, we have used some sensors. In the video you will see immediately about light, CO2 and noise that gather the information, and it's sent via MQTT to a on-premises edge node that would concentrate this information via IoT agents and will send via Wi-Fi, that could be in the real scenario, for instance, 4G, 5G, other communications, to a central servers which would be storing and which would be executing all the pixel framework that we have presented, and that could, let's say, offer the visualization to the user on this PEI evolution, how it has evolved during the time according to what could be happening in one port. So, with nothing else, just let me play the simulation for you to check it. Please, I would kindly ask you, in case you don't hear it, let me know so that I can just share other screen, which I have also prepared the video. So, now here it goes. Hello, my name is Ignacio Lacalle, and as I have just told you 1 second ago, I'm going to present what we have prepared for demonstrating pixel and in particular the Port Environmental Index. As I have explained in the presentation, this demo is oriented or is aiming at demonstrating how one vessel arriving to the port and generating some operations at the seaside port generates some real-time information measured thanks to the pixel IoT framework, and as well it can be seeable how the Port Environmental Index represents the retrospective influence or in performance from the port towards the environment. So this would be, well, it could happen when, for instance, one vessel would come to the port, announcing itself its way to the port, and will generate CO2 because it's fueled by diesel fuels. It will also create some light, and as it can be seen, the values of CO2, light, noise are changing, and the PI of the last minute, as it's a retrospective tool, clearly decreases. Afterwards, although the CO2 starts going down, the noise would still be present because the operations the operations of the terminal in this case, one crane would take up one container, for instance. We are just simulating what could be an operation of the terminal, and we would see the CO2 would be going down as the vessel probably would have stopped its engines, but we would see that the noise still goes up because this is still making some operations. So, and we could see now, checking the evolution of the last minute of the PI, how we observe the PI is increasing, or it's improving better, it's performing better. Why? Because the vessel is going and the operation is ending. And what we could observe here, apart from this demo, apart from the pure values of the PI that are going down and up depending on how the vessel performs, we can observe the evolution and the possibility through Pixel to observe the evolution of the data in this case, one sensor for light, one sensor for noise, and one sensor for CO2. We would observe that now again the vessel has gone some time, but still CO2 affecting the environment is still there. The noise has been reduced, so it does not affect so much. And this would be what the demonstration would be aiming at. Represent that when one vessel comes and has some effect, and also the terminal operations, in this case, one crane operating one container, would implicate in real time. In these screens, you might have observed, if you have taken into account, how this information is going down from the sensors, because all of this is being gathered in this edge node that is being in the Pixel infrastructure that sends through following IoT normal standards to a central server in which all the data acquisition and the central service of Pixel are stored. In this case, data is being sent via Wi-Fi, and via radio communications, 3G, 4G, for instance, for all the protocols. And for ending this presentation, we would like to bring to attention that these sensors would be one example of how the port could get information relevant for the PI, but in the case of Pixel, in the case of the Pixel port, of course, this is just a demonstration. And in the real time, these sensors are much more complete, much more accurate, and also you can go 1 second here, and also in Pixel, how the PI is constructed has many more data than we have now. As you can observe, here the tree is just composed by CO2, noise, and light, PI, and pay, and in the case of ports in Pixel, these are clearly greater. You will see now, of course, the PI is improving, no vessels are now coming, and we can observe in time how these have evolved, and also how the last execution of PI would serve as the data that has come. Thank you very much. This has been the demonstration. For any question, I am here to answer. So thank you very much. I hope you have seen it well. In case you don't, rest assured that this will be uploaded to our channels, and you will have the opportunity to check how actually the data was going up and down during the demonstration. And of course, for any question, I am now here to answer it. Thanks.
Thank you very much, Nacho. Thank you very much also, Stepan, for the presentations, and the video, which is very explanatory regarding what Pixel is, what it does, and how it works. Although it is a scale model, I think we all got a look of what it actually does and how PI works. I encourage our attendees, if there are any questions, to please go ahead and ask. We can go back to Nacho and Stepan later on if you think of any questions. Right now, we go to Joao again, who will give us, who will make a presentation regarding the Pixel Association and the members, how to contribute, the goals, how to contact, how to request services, etc. So, Joao, if you could please close this event by sharing with us your presentation about the Pixel Association.
Thank you, Leonidas. I believe that you see my screen and you're seeing my presentation.
Yes,
and you're hearing me. Yeah. Okay. Okay. Good. It has been a long and very fruitful event. I would to close this event and to have a final release of the Pixel solution and the Pixel Association. I'm going to go back to one of the first slides that was presented here and showing how or discussing how Pixel brings the opportunity through this narrative of connected tools through the Pixel platform that actually fit very clearly one stabilized problem and then actually differentiate across that. Obviously, the problem being this environmental performance measurement, the quantitative measurement, which is quite innovative, plus the IoT based data-driven measurement, so that it is also possible at each time doing so. The security of dealing with the data and the carefulness that we put in dealing with that data is also very important. For us to have the maritime industry stakeholders that are now entering this digital era, coming from maybe a little bit less sometimes, especially when thinking of small and medium ports, coming from maybe less modernized workflows to something that they can trust, they can understand, and that is meaningful for them. And that's how Pixel thinks and is becoming and becomes an NGO. It becomes the Pixel Association. First of all, to ensure that the efforts, the continuous efforts of bringing the Port Environmental Index into an industrial standard continues. That we will focus mainly on promoting this vision of the sustainable ports through IoT, through data-driven technology, across several partners that have already accepted being active members of this organization. most of the technological providers actually, and ensuring that besides the this going to that aim in terms of exposing the benefits, further exploring the technology, further exploring the research potential and addressing the needs, the growing needs of on the industry. It also has technology on the back of this association. So it's an association that aims to position the topic, but position itself also as a technological provider. As a technological provider, there's tools that can be provide consultancy, that can provide tools, that can provide software as a service at some point, that can provide software as a service solutions based on those technologies, that can provide customization of those technologies to better fit the ports, just like we discussed earlier in the beginning. And obviously they can participate in new project proposals and initiatives and be live and eventually include new members. So how does this work? We are using the model where there are two types of participation. One of them being of active members who have a few meetings, quarterly meetings, and will be the active members will be more engaged on identifying business opportunities, identifying leadership opportunities in certain areas of innovation, market areas where things fit well, and obviously areas where collaboration makes sense. Where we can further develop the Pixel solutions, where we can, based on contracts and revenues, that will help to sustain this technology. Also considering adoption on premises, obviously, and communicate. In the end, communicate the value message to a wider and wider Pixel audience. The project started in May 18, and it's now it has been already gaining momentum quite a lot. It has its technology is being is already at use in the ports that were in Pixel, in Bordeaux, Monfalcone, Piraeus, and Thessaloniki is being tried in other ports, and is showing great benefits for those that use it, and further requests for new developments, new features, new things, and grow with those needs, and grow into other opportunities. It was it also it's a momentum. It's not in a closure like the project is. It's actually a pricing. It was part of the emerging technologies in the green tech by the event last week by the Port Technology International. Together with the leaders in innovation on this area, like Inform, Nextport AI, and so on. A part of Antwerp, obviously, and it's going on the direction that it's going on a more and more clear direction. able to accept also at some point to accept also members, either active members or observers, depending on their intent of taking part, recommending and taking some participation on this movement. Maybe I'll give the word now to Nacho to give some final words.
Yes, thank you very much, Joao, for a great presentation. And I would just like to say that the foundation, the creation of the Pixel Association, as Joao has explained, is just the natural consequence of some actions that have been outlined even during the session today, in terms of collaborating with AVP, collaborating with external ports that have officially expressed their interest and intention of testing Pixel and advancing on their knowledge of our tools, the potential continuous collaboration with initiatives like the Network of Excellence, directed and coordinated by Alexio, that has presented before. So we have had the feeling and the impression that although the project is actually over, will be in a couple of days, the path and say the pathways from Pixel towards the future and its potential contribution to bring the smart ports and smart port cities to the place they need to reach has just begun. So we would like to channel and to funnel our activities through this association, in which some Pixel consortium members are already in the very foundational stage. So we are very happy and very eager to continuing our actions towards and through this association. So in case any of you has, say, has rung some bell on their minds about what Pixel could contribute to them or their business or their vision of their ports, both from the technical perspective, IoT, digitization, digital twin, just-in-time logistics, modeling, performing operations, or in the side of, say, the more environmental side of things, the impacts, the sensors, how it's measured, how it can be comparable, how it can be quantified. However, or if you see that this could be of help or of support of your activities, Pixel Association is the entity you must contact. Unfortunately, at this point, we cannot yet, because it has not been found yet, it will be during the next few days. We cannot provide to you yet all these contacts through the website and all the definitive brochure, but we wish that today to announce that this will be a reality in the next few weeks. So please keep up trying to get keep updated to our news and to our positions, and yeah, we sincerely hope to keep our contact with you all for the months to come. Thank you from my side on behalf of Pixel coordination team, and thank you all for participating in the session today. It has been a real pleasure to present. Thank you.
Thank you very much, Nacho. I would also like to thank everybody for participating in this event today, both the presenters and the attendees. It has been a very interesting presentation. And as you said, this is not over yet. This is closing as a project, but we see a lot of potential ahead of it. So thank you very much, and see you again.
Thank you very much, Leonida and all. Thank you for participating in Pixel. Ciao.
Bye. Ciao, thank you.
Bye, everyone.
Bye.
Thank you.
Bye.
Bye.
Thank you. Bye. Bye. Thank you.
Thank you.